So the question is, what is the pH at 25 degrees Celsius of a solution which has 0.050 moles of sodium acetate added to 1 liter of 0.10 molarity acetic acid? So the first thing you want to do is create an equation. So you have your equation here, which is acetic acid plus water in the liquid state, which will ionize to create acetate ion and hydronium, or hydrogen ions. And hydronium H3O plus is the same as H plus. So the next thing you want to do is create an ice table. Water is not included because the ice table, what you want is the equilibrium. And at equilibrium, you have K, your equilibrium constant. And for K, water doesn't matter because the only states of matter that matter are aqueous and gas. So what you do is you look at the information given, and they give you 0.10 molarity. And remember that for ice tables, only molarity goes in here. So then you have 0.10, you have 0.050 moles. But remember that since it's only molarity, you actually have to divide by the liters, so it's 0.050 divided by 1, which will just give you that. And then since they don't give you a concentration, it's 0, because this is initially. So then since it's 0, obviously products have to be made to increase this. So it's going to subtract an x, plus x, and then plus x. And if you think about it, it can't be subtraction here, because if you subtracted it, it would be a negative molarity, so that wouldn't work. So from here, you have equilibrium. What can you do now? So from here, you can do your equilibrium constant. So you just plug in the products and the reactants. Products go on the top, which is on the right side of the equation. So you have your products, 0.050 plus x, and then x. And then you have your reactants, which is 0.10 minus x right here, equilibrium line. And then so you plug in everything in, you get your Ka value, which will probably be given to you. So once you have Ka, a simple rule is that if the exponent is less than -4, then you can make x negligible. Because if you think about it, this is such a small number that even if you added or subtracted to this number, it wouldn't even matter. It wouldn't even affect it that much. So it will simplify to this. Now you just multiply each side by 0.10, divide each side by 0.050, and you'll get x as 3.6 times 10 to the -5. And just to make sure x is accurate, what you can do is you can take this x, divide it by your initial concentration of the acid, the acid, and then multiply by 100. This will give you a percentage. If that percentage is less than 5%, then this is accurate. So now since you have x, we can stop and think about what is x. So x is this line here, right? So if you plug x in, what does that give you? It gives you the concentration of hydrogen ions. So x is the concentration of hydrogen ions. So what can you do with that? Remember that the question wants us to find pH. So now since we have hydrogen concentration, how do we convert the hydrogen ions to pH? Well, there's a formula. pH is equal to negative log hydrogen concentration. So we just plug that in, and then we get our pH. And that is the final answer.